Hi everyone, my name is Sher Wen from School of Mechanical Engineering. For the course EPP 212 Advanced Manufacturing Engineering, we were given the topic we have to study about the technology and also discuss about the future front for this technology. So the topic I was given is friction stir spot welding of dissimilar material. So for friction stir spot welding, it is the derivation of friction stir welding, and also it is similar to friction stir welding where it is a solid state joining process, and also it join overlapping workpieces. So there are four steps for the friction stir spot welding. The first one is rotating, second one is plunging, third one is stirring, and also the fourth one is retracting. This is the figure where we can see for the friction stir spot welding. So for friction stir spot welding, the rotating tool will rotate in high angular speed. Then it is plunged into the workpiece in high pressure. After the plunging process occur, the stirring process will occur afterwards, which is the heat generated during this process, and so solid state joining occur in this process. After that, the rotating tool is removed from the workpiece. As we can see in this figure, the rotating tool is rotating in angular speed, then it is plunging into the workpiece. So this is the stirring process where solid state joining occur, and also the rotating tools is removed from the workpiece. So the process parameter are rotating speed of tool. The rotational speed increases, the temperature also increases, so it is more efficient for stirring and mixing both material. Therefore, it reduces the welding time. The next one is plunge rate. The plunge rate is controlled at a certain rate to generate sufficient heat to soften the material and also reduce the axial force. The reduction of axial force is important because if the axial force is too high, tool life decreases. So we have to control at a certain rate. The third one is plumb depth. It will affect the weld strength, so the plumb depth must be sufficient to avoid fracture. Because if the plumb depth is too high, material bend upward and the gap will occur between the both material. This is the stirring time where this time is provide energy for the burning area. So the dwell time is controlled to a desired temperature for material flow. Microstructure evolution. Since friction stir spot welding is a solid-state joining process, evolution of microstructure occurs during welding. So recrystalline structure form at distal zone, where there's an annulus occur at distal zone, and also a structure contain fine grain is fully formed at distal zone. Friction stir spot welding, there's also advantages and limitations. For the advantage, there is joint dissimilar material where, for example, polymer, alloy, metal, and non-metal. The second one is green welding process. No harmful emission and grinding waste produced. The next one is low energy consumption. Heat is generated during friction and also plastic deformation. So the only energy required is electrical energy. The fourth one is weld strength, joint and also weld strength is better because it is not sensitive to surface condition of workpiece, and so there is no distortion and shrinkage of the material. Temperature will not rise above the bulk melting point, so there is no distortion and so shrinkage. Limitation, there's acid hole remain. This will reduce the joint strength at the keyhole, and also there is also formation of intermetallic compound. This will reduce the amount of strength for the joint and also higher fatigue life, and also lap shear strength decreases. The third one is heat affected zone. For this heat affected zone is near to the stirring zone where the microstructure will not undergo plastic deformation, so the hardness at the heat affected zone is lesser. As you can see in this figure, this is the heat affected zone and this is the stirring zone. This is the keyhole. So this hook is the annulus occurred at distal zone. There are few applications for this welding process. The first one is automotive, which is mostly used in the radar. As we can see in these two pictures, there's friction stir spot welding, and also aerospace industry. We can weld the cockpit doors for helicopters, and also real vehicle construction. which attach shingles to roof panels of train and also aircraft skins. For friction stir spot welding is mostly focused on improving the joint strength properties of materials and improving the joining of dissimilar material. So the first one we should discuss is about the material flow during friction stir spot welding. For the material flow is important because the microstructure of the material will affect the mechanical property of material. So for the welding process, we want better mechanical property of material. So we have to study about the temperature required for the material flow and also other process parameter for this material flow to increase the mechanical property of material. The next one is keyhole produced after welding process. This is the main reason because it will reduce the joint strength. So we should focus to improve the joint strength of the keyhole. From the study, by adding powder can increase the average joint strength for this keyhole. So these are the study from my view about friction stir spot welding. Thank you for watching.